So this is the orientation class about deep learning. So one of the very interesting subject. Let me explain why this selective is introduced as a part of the MCA 4th semester as an elective 3. Both the subjects of social network as well as deep learning are elective 3s. You are supposed to choose one elective out of the 4 in elective 3 combinations. In elective 4, one more set, elective 4, the other 4 subjects, you are supposed to choose, okay, one subject. Okay. So this deep learning is the extension of machine learning is. And again, machine learning is extension of artificial intelligence is. So meaning of this one is called machine learning is a subset of artificial intelligence. Deep learning is a subset of machine learning is. While you see called artificial intelligence, you have gone through in the second semester, machine learning third semester, and deep learning is fourth semester. So there was so much of work happened before introduction of these subjects and already said to you, and also to introduce these subjects we done so much of homework. So how these subjects helps the students are. So we had so much of a great plan in introducing of these subjects to you, because in the fourth sem it's not possible to offer as a core subject of deep learning, because electives government said only offer only electives. So based on the university guidelines we are offering only elective subjects only, not the core subjects. So you're supposed to choose the either your interest based on the previous interest, whatever happened is called based on your whatever you have learned both in artificial intelligence and machine learning, that helps you to understand this particular concept of deep learning is. Let's see why this subject is so important one as an elective for you. The artificial intelligence is early artificial intelligence still excitement, right? Machine learning begins to flourish. Deep learning breaks through the all drive AI boom. You can see this diagram is the sets we have artificial intelligence, machine learning, and deep learning. So the theory and development of computer systems able to perform tasks normally requiring human intelligence. So we use human intelligence, right? Machine mimics the human intelligence to behave. That is artificial intelligence is. To go to more and more, behaves it not only behaves. I would like to train the machine so that it performs like human. So instead of here now, every time I teach the machine how to do it, the machine starts learning. Automatically, it's possible for us to expect to predict the outputs also. Machine learning, what happens is not only mimics the human behavior, it also learns from the algorithms. So gives computers the ability to learn without being explicitly a program. It's not required to write the program. Machine learns based on the data. It learns and starts behaving. That is. Now we go to deep learning is more powerful than machine learning is, and it is a subset of deep machine learning. What you have is called deep learning. Machine learning algorithms only exist here, but brain-like logical structure of algorithm called artificial neural networks. So the word of artificial neural network already we have come to know as a part of this third unit in the machine learning. Expansion of this particular machine learning algorithm of artificial neural network is deep learning only. You can say that. So now in this deep learning, what you have is called, it works like a brain. What are the brain structure is involved? Like that, it starts working like that. Logical structures of algorithms, it frames the logical structure of each and every algorithm is. You can see the picture here, the difference between a machine learning and deep learning is a question comes in any number of times in our mind also. What is the difference between these two machine learning as well as deep learning is? So whenever the input is given, you're supposed to identify what exactly the object is. Machine learning, how it performs to know that input in this example is given as a car. How the machine says that it is a car. To say this is called a car, there are features to be extracted. There is here now called machine learning, the features to be extracted, each and every feature. Then we need to identify based on the features, it belongs to which type of set. It's a car, or it's a bike, it's a what is it called? It's a lorry, it's a bus. Based on the features, it's possible you can make it a classifications, classify based on the features. You have to classify. And more number of things are falling into one of the class based on that is possible. You can say that is a car or not a car. It's possible. While the deep learning is not like that. So here in the previous one, separation happens. Feature extraction and classification happen in a separate one. But in deep learning happens as a single unit. So feature extraction and classification happens in only one unit. You can see how there are layers are exist as compared to artificial neural network. There are layers exist. Perceptron is one of the question raised many number of times. So like that, here you have single layer network as a multi-layer networks, right? Exclusive OR gate, AND gate, all you have seen how to implement all these things. It looks like a gate we have for AND gate, exclusive OR gate, like So feature extraction and classification happens in only as one unit, and face is a car or not a car. So to do this type of deep learning, there are algorithms that exist. More number of algorithms exist. Expansion of the machine, what do you call artificial neural network, is possible in the deep learning is. The deep learning algorithm doesn't need a software unit to identify the features, but it's capable of automatic feature engineering through its neural networks. There's a difference between those two things, machine learning versus deep learning. So you can see that is called a superset of deep learning, and deep learning is a subset of machine learning. The data represented machine learning is quite different as compared to deep learning, as it uses structured data. Machine learning uses the structured data, but deep learning uses the both type of data. It's not compulsory. You should provide structured data. In the deep machine learning, we have given table type of data is to prepare the trees. A table is provided to you, so that it's possible for us to create a particular tree. But in the deep learning, it's not required to provide the data in structured form. That happens, deep learning is quite different as it uses neural networks. Okay, example, face recognition. These type of the applications of deep learning. Sir, let's wait. I tell you. Machine learning is an evolution of AI. Deep learning is the evolution of machine learning. Basically, is how deep the machine learning is. So deep is a word. Okay, that's why first diagram I have shown the deep ocean. I have shown to you. So depth, you are going depth. What is the to understand the entire concept is you're going in-depth analysis happening. Machine learning consists of thousands of data points. That's all. But in deep learning, millions data points are exist. Outputs are machine learning are numerical value like classification of score. But in deep learning, anything from numerical values to free-form elements such as text, sound, image, video, audio, all these things are possible applications in the deep learning. Machine learning uses various types of automated algorithms that turn model functions and predict feature action from data. Deep learning uses neural network that passes data through processing layers to interpret data features and relations. Algorithms that detect by data analysts to examine specific variables in data sets. Algorithms are largely self-repeated and data analysis once they are put into the production. Machine learning is highly used to stay in the competition, learn new things. Deep learning solves complex machine learning issues. Many issues are possible to solve in the deep learning. If you seek our exact meaning of deep learning is okay, 30. Okay, people said, okay, I'll write down 42, 30, 49, 57. You're supposed to write it down, right? The definition is called type of machine learning and AI that imitates the way the human gains certain types of knowledge. It is an important element of data science, which includes statistics and predictive modeling. We the humans always learn from the situations. For example, what you have is called is if you to say that the child an apple and difference between apple and a ball, teacher explains the difference between the apple and ball and explains it. What the kid does is kid starts learning about difference between apple and the ball, right? Suppose now you are now called to identify each and everything. What you have image is the most important object that goes inside very easily. Like that, what you have is called deep learning also does that one. What are the applications of Tom Mitchell said is called? A feature what you have is called machine starts learning using algorithms, using the data, structured data, as a text, as an image like this. In feature what you have is called by using a demo it is possible. So you are doing some demonstration about a particular object what it does is called. Okay, well, how does a machine works? You're doing a demonstration. Machine observes the entire thing, records the entire what are the operation is happening is, and it learns from that one. Next time it does on its own. Machine learns by using this algorithm. Can machine learns by doing some demonstrations by the humans? That is also one type of the new type of algorithms. From Tom Mitchell, what he said is about that. This Tom Mitchell. Tom Mitchell is the person who wrote the book of machine learning, very world famous textbook machine learning, and which is a prescribed book for every university says it's a prescribed book. I have prepared a video also of Tom Mitchell definition about what is machine learning is. This history about that machine deep learning is and its principles. We can compare deep learning with human brain is called. Right side you can see called human brain. What do you have is called. So we try to here now called recollect entire things. So when you met your friend after 20 years or 25 years, you forgot him And you are saying that I know you very well. We met each other long before. And let me recollect you. So in the recollection, what happening is you are trying to connect the neurons. What are the neurons we have? You're trying to connect it. So it's possible you can recognize the particular person, who is that person is. Like that, the machine also tries to do that same type of operations. It tries to connect the pixels. It makes the pixels, makes edges, makes the object parts, and makes the object model is called. Look at this. Pixels will be connected using edges, and edges here in a combination of edges, and comes the a model comes to the picture is called. Like example of face recognition happens like this only. Technology is called one of the algorithm is called CNN is one of the algorithm. Convolutional neural network is one of the algorithm. You have layers you can see called M-1, M and M+1 layers. Right side you can see that. So CNN exploits the spatially locally correlation by enforcing a local connectivity pattern between neurons by existing layers. The next one is the RNN. Recurrent neural network is also called recurrent because they perform the same task for every element of sequence with output being dependent on the previous computations. Have a memory which captures information about what has been calculated so far. Whatever the calculated so far, it takes that one and knows that is called how much calculation happened is called. Example, you can see this is called this one, M and M-1. So layer M, the operation is happening. And layer M takes the information provided by M-1 also into consideration. So recurrently, it uses the calculations. The third one is called long short-term memory, LSTM, is one of the famous algorithms. So it can learn very deep learning tasks that require memories of events that happened thousands or even millions of discrete time steps ago. It works even when they are doing delays, and it can handle signals that have a mix of low and high frequency components. This is one example. So image recognition 504192. How machine identifies this number is called. Example of CAPTCHA is one of the concepts where it's possible for us to apply the deep learning concepts. Right? So this is a training example I'm talking about. The next one is called formulations. What do you have? It can be for the use for prediction, making, ranking, as well as regression is also considered feature is called. Advantages are, so you do feature extraction, no need for engineering features. Moving towards raw features, better optimization, a new level of noise robustness, multitask and transfer learning, and better architectures. It's possible you can make this type of better architectures are possible for the architecture model. So better models are possible to make it using this type of deep learning is. There are challenges are there. The biggest challenge, large data set is required. Biggest challenge is you need large data set. Training time is usually significant. The scale of the net's weights is important for performance when the features are of the same type. Parameters are hard to interpret, and the hyperparameter to non-trivial. Real-time applications. So you can see this one is automatic colorization of black and white images, automated machine translations, object identifications, automations, automated text generations, automatic image capture, okay, and the feature scope is called. Speed search for extraterrestrial life, example Mars, okay, it's possible for us to know entire things is possible by capturing image. To know exact image, what is that is called, we need to deep understanding. The deep learning comes in picture. Robotic exploration, exponent recognition for exoplanets that are beyond our solar system is called. For astronauts, next step on journey to space will be virtual. Droughts and deep learning measures water where it is scarce is. So this is a conclusion about my lecture. Low maturity of deep learning and applications such as large deep neural network achieve the best results on speech recognition, visual object recognition, and several language-related tasks. Field warrants extensive feature research. Nevertheless, the possibilities of deep learning in future are infinite, ranging from driverless cars to robots exploring the universe and to what not if the upcoming architectures are creative enough. So this is the subject of deep learning for you as well as social network analysis. One more time, all of you note down the numbers. All of you are at 57, 49, 30.